Okay. Hi, welcome everybody. My name is Nicole Ballantyne. I work in the manufacturing team at the KTN, and welcome to our fourth webinar of the series. Today we're going to be talking about factory floor and production systems. So KTN, just a quick, who are we? So KTN are here to connect for positive change. That's business to business, academia, investor, with our wealth of knowledge and expertise from across all sectors. This is a slide showing where our sector expertise is. We're experts in network innovation and have been the Innovate UK trusted partner for many years. I'm so excited that we have got this opportunity to develop a network for the manufacturing made smarter innovation part of the Made Smarter programme, and we've invented this webinar series to address all the issues around innovation in the Made Smarter Industry 4 playground. So first of all, I'd like to set the scene about why we're doing what we're doing. So in 2016-17, Jürgen Meyer led a team of UK industrialists to create a vision for the acceleration of digital technologies in manufacturing to improve productivity. From that review, there was four main areas of recommendation. They were adoption, innovation, leadership and skills. So the adoption activity has been taken up in the Northwest pilot, and is now being rolled out to 4 other regions in the UK. That's very much around adoption. And is kind of a capital investment program. The leadership and skills part has been led by Ingenuity, which used to be SEMTA, and you can see all about that program on their Engage platform. And finally, the innovation strand. The innovation strand of the program is led by the Industrial Strategy Challenge Fund team at Innovate UK, and the program is known as Manufacturing Made Smarter Challenge. This is an ambitious innovation programme which over the next 3 years will invest £300 million in supporting manufacturers, digital technology developers, founders and academics to innovate solutions to support the increase in productivity in the manufacturing sector in the UK, and also to export technology solutions to the global manufacturing community. A number of the interventions are already underway. For example, CR&D1, you can see there on the left, CR&D being collaborative research and development. The Fast Start programme started about 18 months ago, and some of those projects are already coming to completion. CR&D2 was the digital supply chain programme, and then there's something else that's live at the minute is the Made Smarter Digital Accelerator, led by DigiCat, and the Innovation Hubs pilot, which is led by the HVM Catapult. Further information on all of these interventions can be found on madesmarter.uk website, which we feel is the central portal for Industry 4 knowledge. The network activity, such as this webinar series, aims to promote the communication of the latest projects, technology and developments, and develop a community of collaborators innovating to support productivity improvements in the UK manufacturing, way past the remit of the Made Smarter funded initiatives. In the webinar series, we wanted to give insights into the art of the possible, starting from the viewpoint very much of the manufacturer. We know that there's very few plug and play solutions for our incredibly diverse manufacturing sector in the UK. And there's always some integration and some innovation needed, and therefore some pain to be experienced before the results start to show. And it's these stories that we're wanting to air. There's so much awesome work going on around the UK, and the Made Smarter Innovation Network and the madesmarter.uk portal will be our way of sharing the stories and spreading the knowledge and success of this vibrant community. We'll keep you updated on the progress following this webinar, and we'll send you information about how you can stay in the loop. So just really super quick, where are we now? Using KTN's extensive technology and sector knowledge, we've set up a programme that will support the Manufacturing Made Smarter Industrial Challenge Fund. We've activity plans in place in all sectors and all technology areas who are engaged with all known networks So we're continually scouting for new technologies that can support the manufacturing sector and are keen to hear and share any stories of change. So on to, I think, a quick update actually. So the Robotics and AI Industry Showcase, which will be the 25th to the 27th of May, we'll send you a link to this, but if you're interested in taking part, this is all part of the knowledge sharing within the Industry 4 arena. So that's robotics and AI. So on to the main reason for us being here. So my speakers today are Rob Woodhouse, who's the Master Production Scheduler from Sheffield Forgemasters. And Rob is going to tell us about the pain and the joy of going from a net score of the very low, maybe he will share that with us, when he was audited by a major OEM several years ago, and now his latest score over the past couple of months was 87%. That's through getting control on the shop floor using the system from our second speaker, who is Mark Carlton. Mark is the CEO of Mestech, and they provide solutions for manufacturers like Sheffield Forgemasters. He'll tell you more about that. Our third speaker is Grant Williams from Kinetic, who will be talking about their Totem product, which is all around electromagnetic spectrum. The reason we brought these players together in this format is when you have Industry 4 and your IIoT and data flowing across the shop floor, have we thought about what is the risk if that signal was blocked or changed or amended in some way? So we wanted to bring that to our manufacturing community today to raise awareness of the risks. And Hazel, our final speaker, heads up the Electromagnetic Spectrum Innovation Network at KTN, which is a cross-sector network looking at electromagnetic spectrum and mitigating the risks to industry moving forward. So without further ado, straight on to Rob, who, as I say, is from Sheffield Forgemasters, is the Master Production Scheduler. He's going to give us a whistle-stop tour about his journey into Industry 4 and alongside Mestech. But Rob, can we hear your story, please? I can see your slide. Yeah.
Good morning, everyone. Thanks for that, Nicole. So I am Rob Woodhouse. I am the Master Production Scheduler at Sheffield Forgemasters. I've worked at the company for 19 years. And as Nicole said, I've been asked to share our experience of introducing a software system solution in order to try and drive improvement to our business. So before I get into that, just a little bit about Sheffield Forgemasters. So we are a large steel making organisation specialising in large forgings and castings, some of which are very demanding and complex customer specifications. Some of our capabilities include having the largest UK forge press and also the largest UK foundry. We also boast a number of large CNC capable machines in our machine shop. We're a 650 staff strong company with some graduate positions and PhDs, and we also boast a strong apprenticeship scheme, currently employing over 60 young apprentices. So I've been asked to share our experience. So to do that, I want to take you back to the beginning. So this is about five to 6 years ago, where there was no software in sight. We collected all our time bookings on paper, similar to the job card you can see on the right there. They were all handwritten by operatives, and I can tell you that some of the handwriting was questionable. That was a challenge in itself, just being able to tell what had been put on paper. They were handwritten by the operatives, as I've just said. It was often filled out by operatives on a Friday afternoon for the whole week. So these operatives were regularly trying to remember what they did on a Monday morning. So the booking accuracy, again, was in question. And again, at the time, I was a shift supervisor in this area, and I had to go around and collect all these time cards in manually. Often I wouldn't be able to find some, and even when I could, they would regularly be stained with a coffee cup ring, sometimes a footprint where they've been trampled on and after they've been dropped on the floor, or a couple of oil stains, which is the environment that we work in. So it didn't look very professional. Our productivity and costs were not often known until we'd actually sold an item. So we had a cost of sales spreadsheet sent round every month, and if that item had been sold that month, that is when we found out whether we'd been profitable or not. We had no live foresight of how we was doing. We often assumed as performance scores. So in the machine shop, we often assumed that we were achieving an 80% utilization. We'd not even considered actual standard performance or OEE, which is something we use to drive as business now. I think it's fair to say that none of us even heard of it. And as downtime, although we knew we got a lot of it, we didn't really understand the main causes or what our big hitters were. And in terms of customer satisfaction and delivery, there was no drive to hit a delivery date. The focus was on keeping machines busy and recovering time. And I would argue that at that stage in our time, a lot of contractual delivery dates probably weren't known by the operational areas, and therefore it wasn't formed in part of the decision making. We had no standardized OTD calculation. Each area measured differently. A lot of these areas scored themselves as 100%, and that was either because they didn't know what they were doing, or they felt unfairly penalised because another department had delivered it late into their department, and therefore didn't want to take a negative hit. So there was no standard approach there. And back in, I think it was 2015, we had one of our key defence customers come on site and carry out a planning and control assessment on us. And I think it's fair to say we scored extremely poorly on that assessment, and the customer registered a cause for concern for us being able to support their business. And I think, in honesty, that is probably the last straw in the decision that we made as a business to reach out to the market for other solutions. So we'd identified that we'd got a problem and we wanted to go out and find a solution. So the objective were to be in a position where we could demonstrate that we could set a plan and follow it to a competent level. We wanted to set off on a journey and improve or repair our customer relationships and start being able to deliver things on time as promised. And we wanted to be able to utilize a system to fully understand the load and capacity, so that when we're quoting for a job at the very beginning of a project, we've got the accurate load and capacity plan in order to quote a delivery date to a customer and believe that we have got a chance of being able to carry that out. And of course, increase profitability, which is what it's all about. So we aim to do this by introducing a shop floor data capture system that allowed us a real-time view of the data, and then having that level of manufacturing intelligence in order to act fast rather than a month down the line when we knew we were losing money. We wanted to know at the moment in time and be able to do something about it. We've got 5 departments at Forgemasters. We wanted a system that showed us the process from the very start to the very finish, and also where we were in the middle of that at any current time. But also be able to use actual data to make decisions rather than an opinion of what we thought was going wrong without any proof. So we'd identified that we had a problem and we wanted to fix it. we knew we had to look externally because we'd previously had a number of failed attempts utilising our existing ERP systems, built-in data collection system. That failed. It was a barcode scanning system. It wasn't up to the complexity that Sheffield Forgemasters is. So we went through a little bit of a selection process, and in 2016, Mestech was identified as the best possible solution for us. Mestech's a cloud-based data collection system. It offers us that real-time snapshot of data, as I previously mentioned, was important to us. It allowed tools for supervisors to be able to manage their team on a live basis, so they could make sure that not only their team logged onto the system, but could make sure they were booked to the correct job, if any job at all. And it gave us that instant analysis through multiple reports. It allowed us to analyze our lost time very quickly, and we had the ability to see very quickly where our problem areas were, which is something we desperately needed. So we agreed to roll this out into one department. We decided to roll it out into our machine shop first. This was seen as probably the least complex area in Sheffield Forgemasters, and we thought we might get a quick win out of putting it in that area first. So we carried out a bit of training. A Mestech consultant came on site with a couple of Sheffield Forgemasters employees, and between them they set up and configured the Mestech system to our needs, probably over I think that probably took about 2 or 3 days. I think what we wanted to do as a business is we didn't want to give all our operatives an individual computer, so what we decided to do was to set up touchscreens spread out in random places around the shop floor, which were in close proximity for them to be able to walk to change the booking, walk back to the machine without causing much heartache. So we did that, but to do that we needed to put the infrastructure in place. So we needed to install a lot of fiber optic cables, buy a lot of hardware and install them. So that took a bit of time, a bit of additional cost, but I think that was key to making sure that the system run as efficiently as possible and gave our operators a good experience while using the system. So it probably took longer to get the hardware installed than it actually did to get the software configured and set up. And then once that were all done, we rolled out the training, and then the Mestech support team were on hand to either point us in the right direction if we were doing something incorrectly, or to provide some sort of customization to get us over a problem that we might not have foreseen. And then in 2017, about 12 to probably 18 months later, we decided that we'd seen some real benefits and it was a success, and we wanted to roll this out to the rest of the business. Behind the scenes, we'd also been doing a bit of a selection process on planning software, and we decided to roll out Orchestrate, which was an add-on to the Mestech system and complemented each other. And because we'd already bought into the Mestech system, we thought that that was the best fit for our company. And at this point, we deployed a dedicated person. In this case, this was myself, to try and oversee the project and roll out to the rest of the business. So that was then. So where we are today, after a journey that I would say is still ongoing, the project's definitely complete, but there's definitely a continuous improvement element where we're still trying to take it a step further and a step further to get as much performance improvement as possible. So today we've got automated interfaces between our 3 key systems, Mestech and Orchestrate and our internal ERP system. It gives us a lot of flexibility in terms of taking away the manual tasks that needed to be done before, but also one version of the truth. So whether you're a shift supervisor or the CEO of the business, you can log on to any one of these systems and you get the same answer. We've got KPIs that are taken directly out of Mestech on big televisions, spread all across the business, proudly displaying our key performance indicators. They're visible to our visitors, our customers, but also to the staff on the shop floor. And I've found from experience that having these visible on the shop floor also drives individuals' own personal performance, as he doesn't want to see his name up there in red and he's underperforming. He wants to, if his name's on the screen, he wants it to be green and look good. So I found that has helped drive personal performance as well as business performance. We've now got actual data-driven planning assumptions built in, so we know exactly how a machine's performing. That is sparked straight into the planning system, allowing us to offer an improved delivery performance. On-time delivery score for 2020 was just below business class, which compared to 5 or 6 years ago is a massive, massive improvement. And I think, to be fair, at the beginning of 2020, we experienced a minor flood event, which put a couple of our key machines out of work for 2 months. So to get that score after an event like that, it is a big achievement for us. And then the planning and control assessment that I mentioned earlier, 2 weeks ago, we resat that again with the same customer and scored extremely highly in comparison to the first time. We're only a few percent outside their goal reward, and some of the areas that we scored lower on were actually customer related issues rather than ourselves. So we were actually marked down for some of our customers' shortfalls. So we were extremely proud of that score. So just a couple of screenshots then. So this is a Mestech system, and it's one of the reports that we use regularly in order to analyze our work centres performance. So it calculates the 3 key areas to drive our OE score, which is then used to drive our planning assumptions. We've got a downtime report. So that same machine that I've just shown you in the previous slide, this shows us the downtime for that machine in that period. So we can very easily see that we've had 6 hours waiting for instruction. We've had 3.5 hours electrical breakdown, and then an hour where the operator has had to stop the machine and go and attend a team briefing. So we very easily and very quickly have the ability to go and see why a machine is performing the way it is. And then this last screenshot, we've got the orchestrate system that we use across site now. You can see the top section is the main planning board. It shows the machine loading for some of our machines for the next 7 months. And at the bottom, one of our key projects where multiple items are manufactured, and at a stage they're all welded together. And we can see that the planning system is, it shows all the links between the jobs and makes sure that all the assembly items are completed before it's ready for welding together. It's a tool that we've never had before, and it's helped us out massively. So last slide now. So over a project like this, we have a lot of successes, but also come across some challenges. So just talking through a couple of them for you. One of the successes or things that we think we did right was setting on that project facilitator, which concentrated on the complex problems that came out of our business and we had to overcome. So that allowed that individual to focus his time on the problem, but also spend a lot of time with the Mestech support team coming up with a solution. We also set on a master production scheduler, which at the time wasn't me. That is the role I'm in now, but the reason behind that position was to try and manage the new system software we got in place, because it was a big change to our business, and it allowed somebody who's got a bit of experience to come in and oversee that. We had the management buy-in from the beginning, which it's so important. We had quite a few complex issues, which meant that the project took a bit longer to get to a close than it was initially anticipated. And because we've got that buy-in and the management knew we needed to get there, it made that much more bearable. Decision making compared to where we were a few years ago, we're in a better position to make those decisions. Communication between different departments, I would argue that they were non-existent before. We've now got a much improved communication, but also a visual tool for somebody in one area to be able to quickly see when an item's due on the machine in somebody else's area. So the communication is probably one of the bigger improvements that's come out of this. We've also dedicated a group planning team, where initially we had a planner sat in each individual department, and sometimes they were putting that department's needs over others. So what we did, we took them out, put them in a central area as a group planning team, so ensuring that the best business decision was made rather than focusing on a departmental need. And then just a couple of challenges that we came across. We had an ERP system at the start of the project, but what we found is that each area was set up differently. You know, not one area was set up the same, so it meant we had a lot of standardizing to do. Because we had the stuff that we do at Forgemasters, long lead time stuff, it took a good few months for all the rubbish data to filter out. So that was a big challenge that we faced. Probably one of the bigger ones, to be fair. Our operational processes are very different in each department, which meant that if we customized the system for one department, that same customization might not work for the next department. So although that isn't a problem and the system does still work as determined, it just meant that there was a bit more time to fix and roll out into certain areas than we did in others. We also decided to change the ERP system in the middle of this project, which was a big headache, mainly through writing interfaces and a lot of other problems, but it did also provide some positives. It gave us an ability to filter out all the bad data that were preset in the old system and set ourselves up with some fresh data that we knew we needed because of the experiences or the journey we'd been on. Training was an issue. Some people, some shop floor staff just are not computer literate, and it took longer to get those individuals trained than it did others. Luckily, the system itself is quite easy to use, so we got there eventually, but it did take longer than it probably should in some cases. And you always get one or two obstructive individuals that just don't want to change their ways. And we call it the big brother mentality. You get people, especially when the names start appearing on a screen for anyone to see. You get accusations of spying. We also found that a few people, the touch screens we put in place have got a built-in webcam, and we used to find that people would put little pieces of tape over the web cameras just to make sure we weren't spying on them, which of course we weren't, and it didn't take long to change that mentality, but at first it was a real thing. People didn't like it. And then the one thing that I would do differently if I did all this again were, we started in the machine shop, which is our back-end process, and that caused us an issue towards the end of the project, because when we did eventually get those front-end processes up to speed and pushed that into the planning system, we found that we'd not allowed enough time for the front-end process to be done in this plan, and therefore it meant that we had to push all those back-end process dates out, which upset a few customers at the time. So that was a one-hit negative, and once that was done, everything was fine. But if we did it again, we would definitely recommend starting at the front end.
Brilliant. So, thank you, Rob. That's awesome, and thank you for your honesty and sharing that with us. You know, the bad and the ugly, and you've had some awesome results, and we appreciate you sharing that with us big time. And I think it just shows that it all takes a bit longer than you think in the first place. And it's a little bit harder than you think. It's definitely not plug and play. Thanks, Rob. So now on to Mark Carlton, CEO of Mestech.
Thank you, Nicole. So I'd like just to broaden out a little bit on what Rob has said about his experience at Sheffield Forgemasters and how we see those sorts of tools applying more broadly across a wide spectrum of UK manufacturing. The problems that Rob has described are common to all the manufacturers we see. I don't suppose there's a person in this virtual room that isn't saying they're trying to improve their safety performance, their quality performance, or their delivery performance at the same time as driving down costs. UK manufacturers tell us that they're struggling to recruit the skills they need to man their businesses, which means they need to work with temps more effectively, they need to multi-skill their operators. They tell us that they are facing an ever-mounting burden of regulation. Nobody ever seems to take away an item of regulation. They never remove an audit requirement. They only ever add to those costs. And all of that's against a backdrop of falling labour productivity in the UK. At first, when I saw that stat, I thought that was some terrible indictment of UK manufacturing, but actually that's a common picture across developed economies. So that's not stalled productivity growth, that's actually falling labour productivity. And yet there's lots of talk of smart factory, industry 4, industrial internet of things and so on. And people seem to be struggling to use the technology to solve those challenges. And the question we asked ourselves is why? And we think it comes down to two main things. Firstly, whilst the business processes that support manufacturing of, say, missiles and cookies might be very similar in terms of raising purchase orders for raw materials and raising invoices for sales orders and so on, the manufacturing processes that underlie those businesses are massively different. And most of the tools that exist require extensive customization to model the intricate details of a given manufacturing process. And what that in turn means is that it's complex and time-consuming to implement with big upfront costs. The second thing is, most of the technology we see is very focused on automation, but for every 73 robots there are in UK manufacturing, I believe there are 10,000 people. So if you focus on collecting data from the machines, you're missing a very large piece of the picture. So we tried to create a system that was configurable and could be configured to model diverse manufacturing processes and had a real focus on labour productivity. As Rob's also outlined, we also tightly integrated advanced planning and scheduling tools into the solution suite. And what that has meant is we're able to rapidly deploy our solutions because of the cloud-based technology. And we've bundled in the services, the consultancy, the training and the integration into the subscription costs, so people can get up and started with absolutely no upfront costs. How do we help our customers though? Well, we do it through digitizing the whole of the manufacturing life cycle. So we break that down into 4 stages: the definition of the manufacturing processes, the planning of the steps and the generation of work to lists for each of the work centers in the factory, the execution in the factory, so the shop floor data collection and the enforcement of the processes we've defined, and the analysis, which is where we drive the real continuous improvement gains. So using that data to drive continuous improvement at each of the stages of the life cycle. So to define better processes, to support planning more effectively, and to support better decisions in real time during execution. I'll just step you through each of those steps in phase: the definition, the planning, the execution, and the analysis. So we provide a single place to define all of the data to plan and execute a job. So that might be the sequence operations, it might be the work instructions, the drawings, the planning constraints, the quality checks that are required, and so on. And we can model the reality of the processes. So you can see here we're modeling parallel flows at the front, we're modeling conditional flows at the back end, what happens if an inspection fails. So we've got a single place to hold all of the data to plan or execute the job. Where that data exists elsewhere in your organization, we can import that. So for example, in Sheffield Forgemasters case, we import the sequence of operations from the ERP system. We then plan the work for each of the work centers in the factory. We believe you need 4 things to be effective in planning and scheduling. So firstly, you need accurate estimates of how long it actually takes you to do stuff in reality, not just some cost accountant's idea of how long it ought to take, how long does it actually take? The second thing you need is up-to-date knowledge of your current state of work in progress, what jobs have been completed, what's on hold, what hasn't been started yet. If you don't know what you've finished already, how could you possibly plan what to do next? Then you need a capacity planning model that can model all of the constraints in your business, be that the labor constraints, the shift patterns, the machine constraints, the inventory constraints, and so on, the power constraints, the space constraints, whatever it is that constrains your ability to make, you need to be able to model those things. But even that will only get you a plan that is right for a moment in time and immediately becomes out of date. To be effective, you need real-time visibility of that plan and achievement against it for everybody that's meant to be working to the plan. And that's what you saw on the screens that Rob showed earlier. When it comes to shop floor data collection, life without Mestech typically has the challenge that people face is three things. Their data collection is expensive. It takes, if you're collecting data on bits of paper and collecting those bits of paper together at the end of the shift or reporting period, you've got three problems. It takes manpower to manage the paper. It's inaccurate. You can't validate data that's written on bits of paper. And you introduce extra opportunities for error as you rekey it into systems. And those are some of the real problems that Rob was talking about earlier. And thirdly, you only have access to make decisions on that data after the fact. So by digitizing that shop floor data collection, you get data collections as efficient as it can be, it's as accurate as it can be, and it's real time. And you can see a couple of examples here. You get some added benefits. So you can see the inspection screenshot at the bottom there, as well as that efficiency of data collection. In this case, that's a quality alert showing a problem that a customer's seen, a customer complaint, photos taken of a customer complaint. One customer took a photo of every customer complaint they had, embedded it in the work instructions of the operation that was the root cause of that fault. In doing so, they halved their customer complaint rate. So something that on paper, people try and put paper alerts in the factory. By digitizing it, it makes a huge difference to the effectiveness. Finally, having done all of that data collection, you've got a wealth of information that you can use to drive improvement in your business. And the key is to provide actual insights to the people that can make a difference at the moment in time that they're able to make a difference. So that might be alerting a maintenance engineer to a breakdown at the moment that breakdown is happening, or in Sheffield Forgemasters' case, it was alerting crane drivers to the fact there was an operation waiting a lift on a machine when that crane wait is triggered. It might be alerting a supervisor to when an operator is short of information, preventing them from working on a job. Or it might be giving a salesperson historical performance when they're costing a new job. To focus on just one example of driving labour productivity improvements, most people's perception of driving labour productivity improvement is it's about making people work faster. Well, in our experience, that's not the bottleneck to labour productivity. The bottleneck to labour productivity is in removing the things that prevent people from working at all on a job. It's not about working fast or slow, it's just facilitating being able to work. And so we've got lots of analysis around labour utilisation. This is an example of a real chart from a real customer showing how they've managed to drive improvement in utilisation. That's the proportion of paid hours that's booked to direct work, how they've managed to drive that up from below 60%, which is where we find most people usually start, to up into the 80s and beyond. And you can see here that one particular team, the green tool room, you can see they've seen dramatic improvement over the last few weeks. When I asked the MD of this company what he did to drive the improvement in that area, it chimed very much with what Rob was saying earlier. So he said, well, what we did was we put this dashboard up on the wall in their department. So sometimes driving improvement can be about complex engineering design change, but often it's about clear communication performance and a little bit of a competitive improvement culture. So what does that mean for our customers? Well, the fact we're cloud-based, we can configure to map to diverse manufacturing environments without customizations, mean we can deliver very, very rapidly with no upfront costs. And our customers see huge improvements in a wide variety of manufacturing performance. So that might be labour utilisation, as we talked about earlier. That might be reducing manufacturing costs. It might be a halving of customer complaints. So thank you very much. If you've got any questions, you know where to find us.
Thank you, Mark. A great range of customers there, from the very large to the very small. Fascinating. So now we go on to Grant from Kinetic to talk about his Totem product. Grant, when you're ready.
Yeah, brilliant. Thanks, Nicole. Great. Morning, everybody. So Grant Williams here from Kinetic. I'm a sales lead for some of our new and disruptive technologies. And as Nicole said, what I'm going to do today is really introduce you to a new detection system called Totem, which is very much designed around supporting efficiency in the autonomous environment, if you say. If we could move a slide on, please. So his way of, or a way of introducing who Kinetic are, because some of you may not know, we're a global provider of science, engineering and technology solutions, core markets to the defence and security and critical national industries. We operate across every domain, so land, air, sea, space and cyber. In particular relevance today, we've got deep specialisms in the likes of autonomy and directed energy, so electromagnetics, RF, GPS, etc. Really what I'm going to cover is the disruptive relationship that exists between those two environments, high level impacts to industries, and importantly then how we can apply the Totem technology to manage this scenario slightly more effectively. If we could move on, please. Next slide, please. Brilliant. Okay, so as a bit of context, and I think we've covered some of this in some of the good presentations already, but over the past 2 decades, what we've seen is our key industries and services rapidly embrace the benefits of IoT and autonomy. And this has given rise to really, I suppose, complex, interconnected environments, smart environments we often talk about in the marketplace. And these systems offer very well documented operational, commercial, even safety benefits to both our industry and even customers alike. And it's important to recognise, because of the I suppose the time critical functions that of these systems, we rely on these smart systems and environments to perform all of the time, or near about all of the time. And therefore they carry very low tolerance levels to any form of disruption. And this is really interesting because I suppose this rapid adoption of technology hasn't come without risk. And what we've seen is a huge the introduction of wide vulnerabilities into our key infrastructure, in particular in this environment, to the disruption from electromagnetics. Because a lot of the systems we're talking about in turn carry their own dependencies on electricity, management of the spectrum, so wireless communication, also a part of complex distributed and connected supply chains, all of which have their own vulnerabilities. And a lot of the systems and environments we've created today have been deployed with very siloed or limited consideration around electromagnetics or the impact of RF in those environments. If we could, next slide, please. Thank you. Now, a bit of context around electromagnetics. I suppose at the highest level, there's small amounts of energy. Yeah? They're created or introduced to our critical electrical systems. And they impact the way our systems communicate, the way they exchange zeros and ones. And that can lead to a disruption of the performance of the products or the asset, or even the denial of the availability. So we're talking about disruption and downtime here. The sources of electromagnetic, less Hollywood, they're rapidly evolving all the time. But in particular relevance, we're seeing significant growth in what we would term as civilian applications. So mobile communication, wearable technologies, access to illegal but highly available jamming technologies, which can be purchased off the internet for GPS interference or disruption, but very, very commoditized. And equally, we're seeing operational and IoT environments actually starting to disrupt with themselves, so competing with their own, I suppose, reliance on electricity by creating transients or actually competing on a narrow band of the spectrum. Now, that's just highlights 2 different applications of electromagnetics, but they both lead to very much, I suppose, costly, undefined, and repeatable disruption. Now, the challenge within the industry, or across all our industries really, is that electromagnetics are by and large undetectable, and they often leave no trace. And they certainly can't be detected by the cyber and physical technologies that we put in situ today, because they're not designed to do so. Now, this represents not only I suppose, a persistent vulnerability within the fortresses that we like to create in our environment, but also increases greatly the scope of impact of an EM event or an RF event within our industries. Could we click on, please? So if we look at or understand the impact of electromagnetics within industry, I think the first thing is to recognize that electromagnetics and RF, they're non-biased. They're indiscriminate. They don't pick a good system or a bad system. They don't care. They seek a vulnerability and they disrupt. And often what you can find is that events in one part of your site or your facility can impact multiple areas. So by nature, they're pan-organizational. And I'm not going to labour the point, because I think we've got a well-educated audience today, but we're talking about operational continuity, the impact to it. So lost hours, lost production, lost efficiency. We're talking about revenue impact, the ability to transact, relationships with our suppliers, with our customers. And in turn, we've also touched on that, then the regulatory attention that starts to attend here. And we've already started to see that in the likes of the NISD, or the Network Security Directive that's recently come into play. But importantly, these are the same risk agendas as to what our cyber and our physical systems, or our risk agenda that we focus all our attention on. So it's logical, therefore, that we start to manage electromagnetics alongside, or even better, in combination with cyber and physical areas. It's part of a more, what we would term as a response and recovery strategy, but a resilience-driven response and recovery strategy. And the resilience is a really key word, because I think that's actually probably well versed or overexposed in terms of the marketplace. And I can explain why and now, and also where Totem fits into that. So if we could click onto the next slide, please. So I suppose in context of our connected environments, or the autonomous environment, and also around electromagnetics, I think resilience starts with the recognition that not everything can nor needs to be protected. So a lot of our traditional workflow processes, so the ability to identify a threat and build protective measures around it, are heavily focused, as we've said, already on your cyber and your physical systems, or your protection or operation. The important thing is those systems cannot detect the threat. And importantly, nor can the response or their recovery strategies cope with an EM or an RF scenario when injected to it. So it's a constant vulnerability. Importantly, in terms of our operational resilience, without detection in this field, you can't evolve, you can't move away from siloed or very, very point solutions towards a really resilience-driven sort of approach. Because I suppose, how do we confidently respond to or recover to something that we don't fully understand? So I suppose in this instance, what we're talking about around our electromagnetics is that they're the missing part of the jigsaw. They're the missing part of root cause that surrounds disruption. And it's important to recognize as well that electromagnetics, they're not a cyber or a physical event, so they don't manipulate data, but they interfere with the exchange of it. So they exist in their own domain, but importantly, their influence, their impact reaches across those domains. So any cyber and physical response also needs to combine with how we all consider electromagnetics and how we respond there. Now, it's key to note that—
1 minute left, Grant. Thanks.
Okay, now the systems support our industries are way behind on this, in particularly because the technology that sits behind this hasn't existed. They're very expensive, or any in-situ stuff at the moment is very expensive, complex, and not scalable to the solution. Now, Kinetic have sought to address this. What we've done is create a product called Totem, which is the market's only electromagnetic detection and alert system. So it's a real-time solution. And what it does is essentially bridge the gap between those domains by giving you the ability to recognize or detect something, so specific EM environmental data, but importantly gives you that data in a format which is very, wants to integrate with cyber and physical responses. So it's making you, I suppose, take a step on that resilience process. Next slide, please. So Totem, it's designed around, as I say, maintaining that disruptive or minimizing the disruptive impact around electromagnetics. The key thing about it is it's real-time detection. It can attribute or discriminate. So it can actually, I suppose, discrimination is as important as attribution around electromagnetics. And then it pushes triggered real-time alerts. So the crux of what we're talking about here is the ability to make better decisions quickly. So it's a physical system. It locates on the wall. It's about the size of a laptop. And what it does is provide continuous environmental monitoring and wideband detection. So it's looking for electromagnetics, RF, even GPS interference. And it does this across an incredibly wide band, so 10 megahertz to 10 gigahertz. And that's unique in the market. So it enables us to pick up devices such as weapons, devices, but importantly, malfunctioning equipment, third parties doing stuff on site, that say welders or in shared data centers. So you've got a security and an operational layer here. And importantly, if it detects an event which is damaging or degrading, it then recognizes that in real time and then pushes an alert into security, central SCADA systems, into engineering hands. So you become more educated in ability to actually respond to the threat. So in essence, what I'm talking about is the delivery of that missing part of the jigsaw. Last slide, please.
Right. You can wrap up. Yeah, thanks, Grant.
Right, okay. And so I suppose the crux of what we're talking around with Totem then is the fact that the key benefit exchange is that ability to make those decisions faster. And also in electromagnetic, but also in a cyber and physical context. So it enables you to save time, enables you to take control, enables you to save money in your environment. But importantly, if you combine it with the cyber and physical, it enables our industries to start to, I suppose, understand the full spectrum of threats and then continuously adapt and update your response and recovery strategy towards resilience and operational continuity. Brilliant. Bit over time there. Apologies, Nicole.
No, thanks, Grant. For anyone that's online, the reason that Grant, you can't actually see Grant's face either is that a lot of the work that Kinetic do is truly cross-sector. So we're bringing this technology across from the defence sector, and his system doesn't allow his picture to be shown. So he has a colleague also online, Johnny Walker, who will be available at the Q&A and in the networking later. So if you have any specific questions for Grant and for Johnny, they will be in the network rooms later. So finally, on to Hazel. Hazel, if you can be super quick, maybe do yours in 5 minutes, that would be great. It's all right.
You always ask the possible, don't you? There you go. So I'm going to be super quick then, and I'm going to try not to be too technical about the electromagnetic spectrum in my presentation. So if I take it back a little bit, if you think about microwaves, cooking our food, talking on our mobile phones, operating our TVs in our home, talking to Alexa or other products do actually exist. All of these connected devices, all of these require spectrum to communicate with each other. And we don't think about the importance of it. We just don't until our mobile phones won't work and we can't get a signal, or all of the Happy New Year things coming at 3 o'clock in the morning, the messages. But what happens when it goes wrong? What happens if that spectrum's interrupted? There was an area in the UK that lost its broadband every morning at 7 o'clock. And it took Openreach engineers 18 months after they did a cable replacement program. They couldn't understand what was causing the problem. Now, it turned out that every morning at 7 o'clock, this little old chap would switch on his old TV, which would knock out the broadband for the entire area because it would emit what's called electrical interference. So imagine now, think about this, if this happened within your manufacturing plant or to a connected device that you rely on for productivity, what impact is this going to have on you? And can you wait 18 months for a diagnosis as to what's gone wrong? How critical is it to you to have a stable and secure continuous access to spectrum in your business or in the technologies that you operate within your manufacturing plant? And I guess realistically, should spectrum resilience be on your organizational risk register? And that's something that I would say, yes, it absolutely should be. So spectrum, you should care because it's a finite resource. This is an image from Roke Manor, and it tells you how much spectrum is used by which particular service providers or which particular technologies. And as we're moving to a more digital environment, we're all going to draw on this spectrum more and more. I've just got a Ring doorbell, I've got 3 or 4 connected devices, my laptop's wireless, and so on and so forth. So even in my own home, I'm drawing on more and more spectrum. We can't make any more. So we've got to look at how can we make sure it's resilient for us. So the Spectrum Innovation Network, this is about helping you and other sectors, the transport sector, smart cities, wearable technologies, you in manufacturing, myself in defence and security, think about what we need for the future. You're all moving wonderfully towards this digital transformation, and exactly what that journey means for you and for others is going to vary from company to company. But it's clear that this wireless connectivity is going to underpin your wide-ranging transformation, your AI, your robotics, your augmented and virtual reality that you use, the industrial internet things. All of these are going to be really important to you. But as Grant was saying, you need to look at this onion peel effect, this layered security effect. What's most important to you as you add more technologies, and what will the effects be of combining all of these together? I was smiling. So we use position, navigation and timing in our cars, don't we? Smart nav systems. And we were talking about to one of the SMEs recently about sales reps. Sales reps don't necessarily like their bosses knowing where they are in their cars and their vehicles all the time. So they bought jammers, and you can buy them off the internet and you can look at YouTube videos about how to develop them and make them work. So actually owning one isn't an offence, but actually using it is actually a criminal offence. And what happened was all of these sales reps tripped up outside a factory. They were all meeting up and they were all going to go down the pub, but they didn't want their boss to know. So as they've all parked up with these jammers in their vehicles, it's had a huge effect on the electromagnetic spectrum within that factory and caused all sorts of problems. So there are unintended consequences of spectrum jamming technologies, which we're seeing more and more of in this country. And we recently had another manufacturer whose CNC machine was causing all sorts of spectrum interference. They identified it to a particular machine, but they still haven't solved the problem of why it's doing what it's doing and the impact of that. So you need to think about how your systems are going to communicate now and in the future. Are they going to be on the mobile phones? Are they going to be on the internet? What happens to your factory, you know, and your technologies if the signals are interrupted? Do you have more than one Wi-Fi internet service provider? So if one goes down, you've still got resilience with another one. So we're building this community and we're working with all of those people that really understand spectrum and within industry, Ofcom, who manage the use of it and sell spectrum and free it up, DCMS, who own the UK strategy, and working across those different sectors and bringing in what we know in the good practice from areas like defence and security into people like yourselves who are going through this wonderful transformation. So we need you to think about, what can we learn from other sectors? What can we do to make sure our electromagnetic spectrum security is considered? You know, what are we going to do about the data integrity, the security, you know, if there's channel leakage, power leakage? And what happens to these accidental breaches, you know, like the guys waiting to go down the pub? Malicious, you know, people are bringing in jammers now and leaving them at railway stations to interrupt all of the boards that tell you when your trains are arriving, not to mention what's going on the trains. There's all sorts of natural and environmental issues going on that will affect your electromagnetic spectrum, and also unavoidable areas. So we want you to start thinking about this. We want you to start thinking about your connected and autonomous systems. We want you to think about your sensor technologies, your robotics and your automation, you know, what's going on there. So there's a good one there, the 5G versus rain radar. So water vapor in the atmosphere produces a weak signal at that frequency. So that's sort of the environmental thing that I was talking about. We've probably seen it, and you've seen it when you go into car parks and people are interfering with the spectrum to make sure that when you think you've walked away and locked your car at service station, you haven't, and by the time you get home your laptop's been nicked. And so thinking about all of those sorts of things. We're also seeing now, as people are using wind farms and that to generate energy, that's causing all sorts of interference with the radar that's used at airports. So the planes are disappearing off the radar because of the wind farms that are being set up. The satellite communications that I was talking about, the position, navigation, timing, operate between 4 and 8 gigahertz on the spectrum, but Wi-Fi and mobile telecommunications use 5 gigahertz. So all of a sudden you've got everybody in that 5, and it's interfering with the satellite communications. And noise that's produced from some of the stuff within your factories, or where you stack up pallets full of stuff, might interfere with the spectrum moving from one area to another. So it's
Hazel, what's the call to action? Can we wrap up, please? Yeah,
we can call to the call to action. So what I would say to you is, be aware of the National Cyber Security Strategy. On the Made Smarter website, there's something in there about the ISCF Secure Systems by Design. Think about putting it onto your risk register, and also come back to us if you're thinking of developing some of these technologies, or you know you've got spectrum interference and you can't work out what to do. Come and talk to us, and we can link you in with people from other sectors that have had these challenges in their sectors that we can apply to the manufacturing sector. So that's me wrapping up, Nicole.
Great, thank you so much, Hazel. So we're going to crack straight on into Q&A. Yeah, we'll just leave the no slides. So I believe there's 3 questions that have been unanswered in the chat, and my colleague Ben is going to voice them. But if you have any other questions, just raise your hand virtually and I'll pick them up. So Ben.
Yeah, thanks all. Thanks for some great presentations. So we have had some good chat going on in the in the chat window. And a few questions, so I'll whiz through them. We're a bit behind time, but yeah, let's whiz through these questions. So a question from Salman to Rob. Do you have any KPI to measure intangible things like satisfaction of your customers. So Mark referred to reducing customer complaints, but yeah, how do you measure the satisfaction? How do you attempt to measure the satisfaction of customers?
So yeah, we do measure it through customer complaints. So we don't do that through the software solution of Mestech. We measure that offline, but we do measure customer complaints, try to act on those in a timely manner. But I suppose the main driver for customer satisfaction is our on-time delivery score and schedule adherence KPIs, which we can measure in the system.
Can I jump in there, Rob? You referred to the audit that your OEM client did. So I guess in a way that is a measure of customer satisfaction, because I assume that you have to get a certain percentage on that audit to continue to supply to them.
Yeah, I think that's right. It's definitely a measure of their view of how we're performing or how we can manage our own processes. So yeah, the fact that we scored so highly in that paints a good picture. In terms of KPIs, though, it is, like I said, it's usually the main ones we use to drive it are on-time delivery and schedule adherence, as well as managing this customer complaint process.
Great. So we've got a question from Jonathan from AMRC, from Mark. Do you have an offering for all size of businesses to deliver shop floor data, data capture and planning, manufacturing execution systems? So I'm wondering if maybe Jonathan's referring in particular to the really small businesses out there.
Yeah, we do, and I think that's something that we feel is novel about our technology. It doesn't require the hundreds of service days to get up and running that many of the alternatives do. So absolutely, we've got SMEs, companies all the way from SMEs all the way up to Siemens. So yeah, a huge range. I mean, there is an absolute minimum size that, you know, if you're a one-man band in a machine shop, our tools probably aren't appropriate, but we're certainly appropriate to them for the vast majority of manufacturers.
Brill. And a question from Jaswinder for Grant. So yeah, this is alluding, Grant, to how the solution from Kinetic, you might have seen it in the chat, is good for RF disruption and the EW warfare space, but I am not sure how useful it is in the current and future everyday cyber environments. So yeah, what's that, Grant?
Yeah, no, I think it's massively important. I mean, this RF situation is only going to get worse, electromagnetic, with the number of devices. So if we lift it in terms of, I suppose it's around cost of impact here. So we're talking about protecting operational continuity. So if your cyber and your physical systems can't detect the threat, how do you confidently respond? And if essentially you could spend a lot of time looking for and a lot of our clients have, looking for cyber problems, or looking into your cyber environment for a non-cyber problem. It's actually an electromagnetic problem which is influencing the cyber environment. So if you don't understand electromagnetic, you can never really get to the root cause. That increases your time of down, it increases your cost of people you're employing and how you're trying to mitigate it, and therefore it increases the impact. So detection is your missing part of the cyber problem as much as it is directly electromagnetic.
Okay, Brill, thank you, Grant. So final one for Mark here. Does the system require hardware integration with machines to collect downtime and uptime of machines? Will this be limited by PLC models?
So it doesn't require it, and except in very highly automated environments, our recommendation is that your starting point is to collect that data within Mestech, but manually. So when the machine stops, you press the button. When it restarts, you press the button. And there's a couple of reasons for that. Even if you have a highly automated environment with lots of modern PLCs and they're all networked and you collect all of that data together, which I think most manufacturers recognize that's not a common situation. You know, you've got to be fairly well progressed to get to there. But even if all of those ducks are in a row, you then only get to know that a machine has stopped because an operator's pressed an emergency stop button. You don't know whether it's because there was a quality fault or because they went for a tea break or because there was an in-feed jam. So a lot of the information is in the people rather than the machines. Now, there is a point where you've collected that data from the people, and there's the next step on the journey is to collect the data from the machines, and we absolutely can do that. You deploy an edge router and connect to the machines through either their existing PLCs or even legacy machines you can connect sensors to through an edge router. But it tends to be the second step on the journey, not the first.
Great. So yeah, so really good to have your questions and answers there. Thanks for all your engagement with the chat, and yeah, I'll hand back now to Nicole to move us into the next section.
Great, thanks. So just I wanted to highlight, we're just wrapping up now. Thank you to everyone that has spoken. Really appreciate your honesty and your time coming to share your stories. Hopefully you find the networking session interesting next. Just a couple of things to point out. There's a white paper released last week, experts from the smart systems integration community presenting views on state of the art and future technology milestones in edge AI. So this report, this white paper, is looking for industry recommendations and commitment and comments over the next 2 weeks. So if you want more information about that, we'll send it in the email when we follow up. And the next one is Innovation Alley at Smart Factory Expo. Tech founders and young companies that are in the arena of innovating in the Industry 4 could get a place to present or to showcase at the Smart Factory Expo in November. And we've started looking for applications now. We're starting the journey and recruitment early this year. And again, we shall send that link. So if there's any advisors on the line working in accelerators or working with young companies innovating around this space, then eager to hear about new technologies and new companies forming. So that's the end of the official part of the presentation part of the webinar, and we're now going to go into the networking section. So I would just like to thank everybody that has come online and listened to the webinar, and please do stay online for the next 20 minutes or so for informal networking, and Anita will put us into networking rooms. Thanks, Anita.